Hi, welcome to the Dynamics tutorials. So in this case we're going to be looking at kinematics, so just the study of the motion with normal and tangential coordinates, but we'll have a fixed radius. So in this case we've got a particle that's moving around this circular path. We know its velocity at point A, which is just right over here horizontally across from the center. And the velocity is changing at a rate of 2 meters per second squared, and that's a constant change. And then down here at point B, we want to find the velocity of the particle, and then we also want to find the acceleration of the particle. So we can draw our normal and tangential coordinates here at point B. So tangential is going to be in the direction of the path, so the particle's going to be moving to the left here at the very base of the circle, and then the normal is going to go in toward the radius of curvature. So since we have a circular path, the radius of curvature is going to be fixed, and it's going to be equal to just the radius of the circle that the particle is moving around. So let's take a look at the velocity. So first we need to find how the velocity has changed. So we need to figure out how far that particle has moved. So arc length is the angle in radians times the radius of the circle, so theta times rho, or in this case theta times r. So it's moved pi over 2 radians times the 100 meters, gives us 157 meters from point A to point B. Because we have a constant acceleration, then we can go ahead and use the integrated equations. So our integrated equation is v squared is equal to v naught squared plus 2 of the tangential acceleration, and tangential acceleration is just the v dot times the change in the position. So this will give us v squared is equal to the initial velocity, 1 meter, square that, plus 2 times the v dot, 2 meters per second squared. Oops, forgot my squared there. Times the distance that it moves, which would be the 157 that we calculated here, and then there's not really any initial position relative to that. So we get a velocity of 25 meters per second, and the velocity always goes in the tangential direction because the particle always has to be moving in the direction of the path. So since the tangential direction is going in this direction, that would be in the x direction or I direction, but it'll be towards the left, so it'll be a negative. So we get that the velocity is negative 25.1 I units of meters per second. Now let's take a look at the acceleration. So we have the AT, which is just the v dot term. So the tangential acceleration in the direction of the path is the 2 meters per second squared. The normal acceleration is the v squared divided by the radius of curvature. Remember, with the radius of curvature, we're just going to use r since it's a circle with a constant radius. So we have our 25.1 meters per second squared that we calculated earlier. Square that divided by the 100 meters, and that gives us 6.29 meters per second squared. And then our acceleration will be looking at the tangential normal. Tangential is going in this direction, so it'll be minus 2I, and then the normal is going in this direction, so it'll be plus 6.29J because we're going in the positive y direction, and units will be meters per second squared. Thanks for watching.